What if the most powerful undersea weapon on Earth couldn't be heard, tracked, or even seen? The United States has developed a new submarine system so silent and stealthy that it redefines naval warfare. Built on decades of acoustic innovation, AI integration, and next-gen propulsion, this invisible underwater weapon outpaces every competitor from Russia to China. Hidden beneath the waves, it gives the U.S. unmatched reach, endurance, and surprise. A true game changer. Becoming invisible underwater. Deep beneath the Atlantic Ocean, where sunlight vanishes after about 200 meters, underwater vessels depend entirely on sound to be detected or hidden. In this vast, silent realm, America's modern attack submarines, especially the Virginia class, aim to attain near-complete invisibility. Sound travels 4.5 times faster in seawater than in air, so sonar remains the primary detection method. But a submarine that produces almost no sound becomes nearly undetectable by traditional sonar arrays deployed by surface ships and enemy submarines. Imagine a submarine gliding through waters at 25+ knots, a speed beyond most patrol craft, yet producing noise levels so low they blend with natural ocean background hums. This is not science fiction, it's the reality of modern acoustic stealth. In a world where active sonar can ping a target at tens of kilometers, silence is the ultimate defense. A submarine that doesn't whisper gives away no hint of its presence. Detecting something quiet in a sea full of whales, weather, and shifting currents is extraordinarily difficult. This stealth revolution began as a goal during the late 20th century when naval strategists realized that future underwater warfare would not be decided by armor thickness or deck guns, but by who could be present without ever being heard. By the early 21st century, the United States Navy invested heavily in technologies designed to reduce noise signatures from engines, propulsors, pumps, and crew movement. Engineers aim to eliminate acoustic fingerprints that traditional passive sonar uses to identify and track underwater threats. Today, silent presence under the waves isn't just an advantage, it's a strategic necessity. A submarine that can remain nearly invisible shapes the future of naval conflict, deterrence, and covert operations. Whether stalking a distant adversary, conducting clandestine surveillance, or positioning for a decisive strike, acoustic stealth provides a tactical edge that few can match. Knowing why a silent submarine matters, we turn to the current embodiment of this technology. In Section 2, we explore the anatomy of the champion, USS Virginia, SSN 774, and her class. Anatomy of a giant. The USS Virginia, SSN 774, represents the pinnacle of modern submarine engineering. A sleek, nuclear-powered attack submarine launched in 2003 and commissioned on October 23, 2004. At approximately 115 meters in length and built from nearly 8 million kilograms of specialized steel, Virginia embodies stealth, endurance, and lethality. Powered by a S9G nuclear reactor, this submarine can operate submerged without refueling for decades, limited primarily by food supplies and crew endurance. Virginia-class submarines carry a formidable weapon suite. They can accommodate roughly 30+ advanced torpedoes and a dozen Tomahawk cruise missiles, each capable of striking land targets hundreds of kilometers away. In addition to traditional torpedoes, the class can support special operations forces, deploy unmanned underwater vehicles, UUVs, and provide covert intelligence gathering. These capabilities are compact yet deadly, fitting within a submarine designed for both deep ocean patrols and littoral environments. Operational depth and speed define another aspect of the class's capability. Virginias can dive to depths exceeding 800 feet, approximately 240 meters, and sustain submerged speeds greater than 25 knots. These performance metrics put them on par with or superior to previous generations, including the Los Angeles class, while offering enhanced stealth. Each submarine costs over $2 billion, with later boats like the USS Colorado, SSN 788, the 15th Virginia-class boat, showcasing incremental improvements in noise reduction and sensor fusion. In modern naval warfare, SSNs like Virginia serve as attack platforms, strategic deterrence, and reconnaissance assets. They patrol contested waters from the South China Sea to the Mediterranean, slipping silently through depths unseen. Their survivability doesn't come from heavy armor or explosive power, but from refusing to be heard. In an environment where detection often equals destruction, being untraceable is the greatest weapon of all. With the Virginia's capabilities defined, it's crucial to understand why such a class was needed. In Section 3, we examine the historical pressures and operational goals that drove its development. Why the Virginia class was needed. During the closing decades of the Cold War, the United States Navy pursued the Seawolf class of submarines designed for high performance and deep ocean dominance. Each Seawolf came with extreme capability, speed, depth, and firepower, but also a staggering price tag of roughly $3 billion per boat. With the collapse of the Soviet Union in 1991, the original threat that justified such expense faded. Yet, the need for stealthy underwater platforms did not. As the geopolitical landscape shifted in the early 1990s and 2000s, the Navy reevaluated its force posture. Without a monolithic rival like the USSR, planners saw the future of undersea conflict as diverse and unpredictable, ranging from literal patrols near Strait of Hormuz choke points to covert surveillance in disputed waters like the East China Sea. A new class of sub was needed that could operate effectively in both deep oceans and shallow coastal zones. Cost was a defining factor. Seawolf-class boats were too expensive to buy in large numbers. Only 3 were built. The Navy needed a design balancing stealth, power, and affordability, something that could match much of the Seawolf's capability without consuming the entire shipbuilding budget. The result was the Virginia class, engineered from the start with acoustic quietness and mission adaptability prioritized over sheer size or maximum firepower. The Virginia class was designed not just to be powerful, but strategically flexible. Its role was defined by a blend of acoustic stealth, versatile payloads, and modular design. Instead of optimizing for one type of enemy or environment, Virginias could perform multiple missions, strike land targets, hunt other submarines, conduct depth-focused surveillance, and support special operations. It redefined what a modern attack submarine could be. Having established why the Virginia class was necessary, next comes the story of how it was built. In Section 4, we explore construction innovations that made this advanced submarine possible. Building the Beast, the Virginia-class submarine program fundamentally changed how the U.S. Navy constructs attack submarines. Technical collaboration between Electric Boat, Groton, Connecticut, and Newport News Shipbuilding, Virginia, launched a split-yard production model in the late 1990s. Instead of building one hull from start to finish in a single location, engineers began fabricating large bow, midsection, and stern modules in parallel. By the early 2000s, this modular approach cut production time by months and reduced assembly bottlenecks, enabling multiple submarines in different construction phases simultaneously. Modern modular construction relies on outfitting pre-assembled sections with piping, electrical systems, stealth coatings, and sensors before joining them into a complete hull. Workers weld calibrated rings together with such precision that each seam's tolerance stays within plus or minus 2 millimeters, essential for stealth and structural integrity at depths beyond 800 feet. Sections are outfitted like floating rooms, complete with internal fittings, cables, and weapons connections, then joined, tested, and pressure checked as a unit, greatly reducing rework during final assembly. This puzzle-like hull assembly also accelerated production. A single Virginia-class hull comprises dozens of these modules, each pre-inspected and digitally modeled using 3D CAD tools dating back to its design phase in the 1990s. Engineers simulate stress tests, acoustic signatures, and hydrodynamics on these modules before cutting metal. These digital inputs feed a single source of truth for builders and suppliers, eliminating mismatched revisions and ensuring faster iteration between design and execution. Perhaps the most significant innovation was the shift from paper blueprints to digital design. Virginia was the first U.S. submarine designed entirely in 3D digital space, which gave planners extraordinary foresight into internal systems routing, stealth optimization, and future upgrades. Every sensor, seam, and support bracket was visualized digitally before fabrication began. This digital revolution not only lowered production costs by hundreds of millions of dollars per hull, but also made upgrades and future add-ons far easier, preparing the class for decades of missions ahead. With the Virginia-class hull perfected through modular innovation, the focus shifts inside. Section 5 reveals the cutting-edge control systems and modern interfaces that redefine how submariners operate undersea. Inside control. The shift from analog to digital in submarine control systems is one of the most dramatic changes in undersea warfare. Traditional submarines use optical periscopes, long tubes with mirrors and glass viewing windows, to peer above the surface at periscope depth approximately 15 to 30 meters. With the Virginia class, these gave way to photonics masts, sensor towers loaded with high-definition cameras and imaging arrays. These feed 4K panoramic video into the sub's central screens without requiring a physical tube piercing the hull. Rather than viewing through glass mirrors, sailors now see the world via fiber optic data links carrying crisp, real-time images from the mast sensors. This method eliminates the structural weakness of a periscope tube and reduces hull penetrations, a key contributor to noise and detection vulnerability. High-bandwidth feeds let operators zoom, pan, and record at speeds exceeding 60 frames per second, all while the submarine remains fully sealed and silent beneath the waves. Inside the control room, traditional manual stations have largely been replaced by ergonomic consoles and intuitive joypad controls, much like advanced flight simulators. These game-style interfaces improve reaction times, reduce physical strain, and enhance coordination between sonar operators and navigation teams. Rather than twisting steering wheels or flipping analog switches, operators use precise digital controls synchronized with millions of lines of software logic to manage depth, direction, and sensor fusion seamlessly. Perhaps most transformative is digital warfare integration. Sensor feeds from the bow sonar array, flank arrays, and mast imaging unite into a single real-time tactical display, enabling rapid decision-making. Instead of interpreting dozens of individual instruments, crews see a unified picture blending acoustic, visual, and environmental data. This data fusion enhances situational awareness while reducing cognitive load, a critical advantage during high-stress operations where seconds can decide life or death undersea. With new control systems enhancing stealth operation, the true heart of the submarine lies in how it moves. Section 6 explores the nuclear and propulsion systems that give Virginia endurance and silence unmatched at sea. Heart of the sub. At the core of every Virginia-class submarine is its S9G nuclear reactor, a compact yet powerful generator that fuels the vessel without refueling for decades, often for its entire operational life of 30-plus years. Designed by General Electric engineers and deployed starting in the early 2000s, the S9G system steams turbines that propel the submarine while keeping acoustic signatures to whisper levels. No diesel engines, no noisy generators, just continuous, silent power. The reactor heats pressurized water, producing steam that drives propulsion turbines and auxiliary systems. This steam conversion is vastly quieter than traditional mechanical drive systems. Next in the innovation chain is the pump jet propulsor, a water jet system housed inside a shroud rather than a conventional exposed propeller. While a normal propeller makes cavitation noise, tiny bubbles collapsing at high speeds, the pump jet moves water so smoothly that acoustic detection becomes exponentially harder. Noise reduction equals survival in submarine warfare. In the deep ocean, sonar operators listen for minute fluctuations in sound, the faint signature of a rotating shaft, a stray pump, or a crew member walking on wet steel. The Virginia class minimizes these risks with vibration-isolating mounts, acoustic tile coatings on external hulls, and sound-damping machinery mounts inside crew areas. Even the rhythm of everyday life, footsteps, doors closing, pumps cycling, is engineered to reduce vibration to avoid sonar detection. Having explored the submarine's propulsion and power, next we'll examine how it perceives the underwater world. Section 7 dives into sonar and sensor arrays, the ears of this invisible hunter. Eyes and ears of the deep. Underwater perception is everything in submarine warfare because sound travels nearly 1,500 meters per second in seawater, far faster and farther than light. A submarine with superior sonar and sensor suites can see enemies without revealing itself. The Virginia-class submarines are equipped with multiple acoustic systems designed to listen silently rather than broadcast signals. At the front is the bow sonar array, a large aperture set of hydrophones that detects sound from great distances, often before the opponent knows it is being listened to. Along the submarine's flanks sit flank arrays, rows of passive listening sensors embedded in the hull's outer surfaces. These wide acoustic ears gather data from all directions, covering blind spots passive sonar alone can miss. Unlike active sonar pings that give away a vessel's position, passive sonar captures the unique acoustic signatures of enemies, from enemy subs to surface ships, and distinguishes between propeller noise, machinery hums, and biological sounds like whale calls. For close-in detection, especially in shallow water and under ice, Virginia-class submarines use high-frequency chin and sail arrays. These systems, positioned near the bow and beneath the sail, the vertical fin atop the hull, pick up detailed acoustic reflections at shorter ranges. High-frequency sensors are especially useful in congested littoral zones, such as the Baltic Sea or South China Sea, where traditional sonar propagation becomes complex due to shallow depth and temperature gradients. With detection systems explained in We Move Next to Offensive Capability, Section 8 breaks down how Virginia carries and deploys torpedoes, missiles, and unmanned systems without compromising her stealth profile. Lethal Reach Stealth is a submarine's shield, but firepower is its punch. Virginia-class submarines are armed for a wide range of missions, from anti-ship warfare to deep strike land attack. The primary underwater weapon is the Mark 48 heavyweight torpedo, a sophisticated wire-guided torpedo weighing over 1,500 kilograms with intelligent homing. Each submarine can carry multiple Mark 48s ready for rapid deployment, capable of speeds exceeding 55 knots and depths beyond 800 feet. For land attack and standoff strike missions, Virginia carries Tomahawk cruise missiles, each with a range exceeding 1,600 kilometers. These weapons allow the submarine to remain deep and unseen while projecting force hundreds of miles inland. The integration of Tomahawks significantly expands mission profiles beyond traditional anti-ship roles to include precision strike against strategic targets, a capability first demonstrated by U.S. submarine forces in Operation Desert Storm, 1991. In addition to torpedoes and missiles, Virginia can deploy unmanned underwater vehicles, UUVs, through existing torpedo tubes or dedicated launch systems. These drones conduct reconnaissance, map ocean floors, or serve as decoys to confuse enemy sensors, all without the submarine exposing itself. Together, this suite of weapons and vehicles gives the invisible hunter not just survivability, but persistent lethal reach across sea and land targets. Stealth and lethality are sustained by the crew and onboard systems. In Section 9, we explore life below deck, how sailors live, work, and operate silently during extended missions. Life below. A submarine stealthy and lethal as Virginia still depends on the people who operate her. Crewed by about 140 sailors, typically 18 officers and over 120 enlisted personnel, life aboard involves long deployments and strict routines aimed at preserving silence and focus. Most missions last 5 to 6 months, limited not by fuel but by consumables such as food and psychological endurance. Space aboard U.S. attack submarines is compact. Corridors may be only 0.9 to 1.2 meters wide, and berthing compartments are shared bunks where sailors sleep in shifts called hot bunking. Despite the tight quarters, every inch serves a purpose. Machinery, pipes, and control systems are tightly dampened to reduce vibration. Even the sound of footsteps can be transmitted through hull steel. Every member learns to move with precision, minimizing noise that might reveal the sub's position to enemy sonar. Daily life aboard Virginia revolves around mission sustainment. Routine checks on life support, including atmospheric management of oxygen, CO2 scrubbers, and humidity, occur hourly. Crew members in sonar rooms listen for hours on end, interpreting soundscapes that might signal enemy contacts or environmental changes. Lighting follows circadian cycles even at depth, and scheduled exercise time helps maintain health on deployments lasting 150 to 180 days. As the Virginia-class continues to evolve, the next generation promises to redefine silent operation. In Section 10, we examine the future, the SSNX program, and what comes after. SSNX. Looking beyond the 2020s, the U.S. Navy has initiated next-generation submarine concepts collectively referred to as SSNX, a future class designed to integrate the best features of the Virginia, Seawolf, and Columbia programs. While Virginia excels at stealth and versatility, emerging threats demand even greater speed, survivability, and payload capacity. SSNX aims to resolve the classic stealth speed paradox, being fast and silent. One of SSNX's core goals is to merge Virginia's low acoustic signature with propulsion systems capable of higher sustained speeds. Estimates, still classified, suggest target submerged speeds exceeding 30 knots, a significant jump from current limits, while maintaining minimal noise output. This requires innovations in pump jet design, hull-form optimization, and next-gen reactor cooling technologies that don't compromise stealth. Payload and weapons integration also evolves. SSNX designs incorporate larger internal volumes and flexible payload bays that exceed the capabilities of the Virginia Payload Module, VPM's 28 Tomahawks. These spaces are intended not only for missiles and Mark 48 torpedoes, but also for expanded unmanned undersea vehicle, UUV teams, hypersonic canisters, and even directed energy launch systems as they mature. Drone integration stands out as a defining feature. SSNX platforms will natively launch and recover UUVs for reconnaissance, minefield mapping, or decoy operations. Real-time data streams from drones will feed into advanced AI tactical fusion systems on board, combining ship, air, satellite, and underwater intelligence into cohesive operational awareness without surfacing. Perhaps most importantly, SSNX will operate within a data-dominant network, merging undersea sensors with distributed maritime domain awareness, leveraging space-based sonar arrays, distributed sensor webs, and AI predictive analytics. In this future, stealth isn't just physical quiet, it's information dominance, ensuring the invisible hunter remains unseen, unheard, and always a step ahead. In a world where oceans determine strategic power, this invisible U.S. subwater weapon ensures dominance beneath the surface. Quiet, elusive, and decades ahead, the future of naval warfare is already here.